right, let's get started. Okay, so you have your PS8 coming due, and PS9 will be out soon and due next week. Any questions or problems? Okay, so one thing you'll find if you take your tests and you write a loop and run a whole bunch of them, run your test over and over again many times, is it appears that I don't know if it's the computer or the runtime system for C# or whatever, gradually starts to degrade and bog down because you're like allocating and deallocating these resources over and over again, tasks and threads, and things that, if you're relying on timeouts, which in some cases you have to, they start to not be long enough and things stop working. So we'll take that into account when we grade. We'll try to be gentle on the machine when we run your test cases. Yeah?
So if all of our tests pass when run independently, but yet you run them all together and you have several that fail?
Well, okay, finish your question.
Anyways, so is that kind of a symptom of what you're talking about?
It can be, or it might be a symptom that you have a race condition in one of your cases. Okay? So, there's certain things all the tests, they have to be done within a minute, right? So you're depending on things running in a reasonable amount of time. But it just seems that after running tests over and over again, you get to the point where things aren't happening in a reasonable amount of time. But one common symptom is if you have a race condition in one of your tests, it might work just fine when you run it by itself. But when you run it in conjunction with a whole bunch of other things, then the timing gets slightly thrown off and it fails. I'm not talking about timing getting slightly thrown off. I'm talking about taking a second to spin up a thread, which is an absurdly long time, but it can happen. It's just in this business it's hard to tell why things are failing. But anyway, the main point of the assignment is to get an appreciation for what's involved in concurrent programming and what the difficulties are and what can go wrong, and we'll do our best to grade fairly. Take the difficulty in consideration. Okay, one thing I want to emphasize is I put an announcement on Piazza and I pinned it to the top. But if there's an unhandled exception in a task that you create, so if the main testing thread creates a task and there's an unhandled exception in it, that unhandled exception will have no effect. It will not cause the program to crash. If the unhandled exception is caused by a failed assertion, the assertion will be ignored unless the main thread is waiting on that task to finish. If it just fires the task and then doesn't wait for it, unhandled exceptions, failed assertions will all be ignored. So if you're putting assertions in a task, be sure that you're waiting for that task to finish in your testing code. Yeah?
Is there anything else besides like assertions that would cause that to happen inside the task? Or unhandled exception? Or is it mainly just assertions?
Well, yeah, assertions is what you're worried about. Unless, it's possible, if you're writing a test that expects an unhandled exception to happen, if you're trying to test for an exception, I would recommend testing for exceptions in the main thread. Okay, any other questions? Okay. We were talking last time about creating REST clients, so I want to complete talking about that today. And just remind you where we were. Okay, hold on. All right, so we had a simple to-do list client that let us register and put things on the list and delete them and mark them completed and so forth. And this is a typical method we looked at, register. This is an event handler that's fired, and it gets the name of a person trying to register and an email address. So that's what's coming in. And it's in the controller class, so it tells the view to basically disable itself while the request is being processed. And this is very typical of interacting with a remote REST server. Is first of all, you've got to know what kind of request are you making. So it turns out that to register a user, it's a POST request. The URL is register user. There's other stuff that goes before the register user in the URL, but this is that's baked into the client object right there. So essentially, we're saying we have an HTTP client we created. We're saying, do a post of this URL and that content. So we give it the URL to post to, and we give it the content to put into the body of the request. And it takes care of making the request, going over the web, getting the answer back, and taking what it gets back and putting it into a response. And if we look at all of these controllers, see here we're doing a post async. Okay, this is where you add a new task to the list. This is a post async to a different URL. Okay, this is deleting a task, and so this is a delete async method, and we just give it the URL. There is no body, and so on. So there's post async, put async, get async, and delete async. Now, as for getting parameters, sending parameters out in one of these requests, okay? So for register user, it turns out that the parameters need to be packaged up into an object and placed into the body of the message of the request. So I create an expando object. I set it a name field to the name I got. I set the email address to the email I got. And then I do this bit of stuff. This is the object I want to send. That's the thing I want to send in the body. So I serialize it, convert it into a JSON string. Then I basically encode it as a bunch of bytes. And that's what goes into the body of the message. So that's typical. If we look down at this one here, same thing happens. I create an object that has user ID and description fields. And I serialize it and encode it the same way and pass it right there. If I want to delete, there's nothing in the body, so you can see I'm just using the URL right there. But I build the URL. The URL needs to be delete item / something, where that something is the item ID of the item I want to delete. That goes into the URL. Then I send it. To mark something done, it's a put request. I put the index, I put the item number up here in the URL, the content's null, make the request. Okay, so that's the game you play. So all these requests end up looking the same, or very similar. So now if I look at what happens after I get the response back, so typically we can, when a response comes back, we can check the success code, or the status code. So if the status comes back as 200 or 204 or anything with 200, that was success, and we do one thing. Otherwise, you're dealing with an error condition. Something went wrong, and you can, I didn't do much except display it, but you can diagnose what went wrong. What's going on right here? So we got a response back. We registered. We got a response back. It said, okay, you're registered. And in the response, there was something in the body of the response. So what are we doing here with that highlighted code? This is the response we got back. So what are we doing to it? Okay, well, response.content is the thing in the body, and we convert it to a string. Now, turns out that when you see a method that ends with async, typically what that means is it creates a task to do what you just asked it to. And so what we're doing here is we're creating a task, and then we're just waiting for the result to come back. anyway, that converts it to a string. Then we deserialize that string. That's a JSON string. It deserializes. In this case, we're expecting a string in the response, a C#. So we cast it to a C# string here. And then we've got our user token back that we need to save. So what you go through is you build up something you want to send in the body, you build up the URL, you send it, you look at what you got back, you turn it into a C# object, and you extract the information you need from it. Yeah?
The deserializing the string, so initially it comes back as a string, but it's not fully a C#.
Well, okay, what comes back is a bunch of bytes. So what this does is it turns it into the actual string that was written by the server. Okay, that string will be the JSON version of whatever object was written there. So there was some C# object on the client, or we don't know if it's C#, but there was some object on the client. It was turned into JSON string, put into the response. We get the response back. This line here is turning it back into a JSON, or getting the string. This, what that highlighted code turns it from JSON into a C# object. And you just have to know what type of C# object we're expecting to get back. In this case, I was expecting to get back a C# string, so that's why it's safe to cast it to string. If what it sent back was a object of some kind of some class, then we'd have to cast to that class. Yeah.
So if we were doing a number instead of a string, would we have to make it? Would we have to be able to ensure what kind of endian is it sent?
I've never worried about that, so I think I just cast it to int. It seems to work.
Could you cast it to dynamic?
Well, you wouldn't even have to cast it to store it in a dynamic. You'd have to. Let's see what happens here. Well, the problem is user token is declared as a string. If user token were declared as dynamic, I could leave the cast out. But but that's not the case here. Now, how do we know what capabilities the server has, the remote server has? How do we know that the URL to use is register user or add item or delete item? Where do we get that information?
The API.
Yeah, you got to see the API, and it's conveniently packaged in this case. If we go to the to-do list server and run it, I showed you last time, that what it does is it brings up the browser of your choice slowly, and you can click on API and you can see the API. So you see, it shows you those 5 things you can do. These are the 5 endpoints that the server provides for you. You can do a post to the register user URL, a post to the add item URL, and so on. And you can read what it does, and you can drill down and see exactly. Okay, this one, the body has to have a user info object, and what you get back is a string. And if you want to find out what a user info object is, well, you can see it's something that has name and email fields. You can actually drill down and see what everything is. So just like anything else, you got to know the API, and then to call it, it's a little more involved than calling a local, just calling, invoking a method on an object on your computer because you're going over the web. So that's what I was just showing you is what has to happen to do that. Okay, so I've got the server running in one copy of this, and I'm going to go back to the client, and I'm going to run the client. And this didn't work for me last time, but then it worked in my office. I'm afraid it's not going to work here again. I'm going to submit stall, and the idea is that I wrote the server code so that if it gets stall as a username, it sleeps for 5 seconds. So if I click register, see everything is deactivated, but everything is frozen. Nothing I can do. And you can guess, you see it lit back up after 5 seconds. What's happening in those 5 seconds that prevents me from using the GUI? Why is it GUI freezing up when I submit and the server takes 5 seconds to get an answer back? Yeah, I deactivate the controls, but I didn't deactivate the cancel button. So let me do this again. The cancel button is activated, but I'm clicking like mad on it and it's nothing's happening. Why won't the cancel button do anything? Yeah, the problem is I'm doing everything on the main GUI thread. Right? I make the call and wait for the answer to come back, and that prevents the GUI from doing anything until I get the answer back. Well, you might think that's not a big deal, because normally servers don't stall for 5 seconds just for the heck of it. But how long does it take to get a response back from the server? Does it take 100 milliseconds? Does it take a second? Depends, right? Network can be slow. So unlike a regular method call where you can be confident you'll make the method call, you'll get the response will come back. There won't be an arbitrary delay. When you're going over the web to a server, you don't know how long the delay is going to last. So you don't want to wait on the main thread, on the GUI event thread, waiting for the answer to come back, or because you'll be frozen until then. So I want to show you how to fix that, and I'm going to do it in 2 steps. First, I'm going to show you sort of a clumsy way to do it, a difficult way to do it, and then I'm going to show you a really simple way that is enabled because C# provides a couple primitives we haven't talked about yet. So to do that, I need to switch over my program to use controller 2. And let's first verify that I've solved the problem. So I will start the thing, and I will do stall. And I will say register, and then I will cancel. And it cancels out. So obviously I'm doing something right here. So let's go look at controller 2 and see what it does. And I think I only made this change for one of the methods because I was a little bit lazy. But submit. Where is register? Okay, there's register. Okay, so this is the code we saw before. Okay, goes on down below, but this is the code that I showed you before. We create an HTTP client, we make the request, we then block until we get the result. So that's a blocking thing. This is happening on a separate, this is an asynchronous call, so it's happening on a separate task, but we're blocking the task, the thread we're on, to wait for the result to come back. So that's a block. Then we deal with the response. What have I changed? What's different about this from the first one? I'll give you a hint. I mean, I already said this is all copied over. This is all copied over down to somewhere here. Yeah?
It's in its own task right there.
Right. So before, this wasn't here. Before, I was just entering the using on the main thread, blocking on the main thread, and then when the response came back, dealing with it. So the main thread was blocked. So to avoid that, what I do is I just create a task here that does all this stuff. So I wrapped all of this stuff into a task. Now I have to, since cancellation can happen, I had to add that catch. And I think I added this try as well to catch the exception that happens when a task is canceled. I'm not showing the cancellation code. But I am showing you, I have to pass the cancellation token in, so I guess I lied, the code is a little bit different. So I'm passing the cancellation token in, and somewhere else, when the cancel button is clicked, the cancellation token is used, like I showed you, to cancel the task. So, but what's the advantage of running a separate task here? So that this handler is run, we enter We disable the controls, we create a user object, we create the cancellation token source, we create the string content. That's all happening lickety-split. Then we create a separate task to do everything, and then let's scroll to the end of the task, and we return. So what's going to happen from the point of view of the rest of the client, of the GUI event loop? Yeah. Right. So essentially, the GUI, this is the event handler. It's handled fast. Register is called. We do all this stuff. None of this stuff takes long. We spin up a task to do the rest of the work, and then we return immediately. So now the GUI event loop can notice that the cancel button has been clicked, if it's clicked, and do something about it. Then sometime in the future, so this task is off running. So this task starts running. It opens the client. It blocks while it's making this call to post async, but it's okay for this task to block. Then it deals with the response, and that happens sometime in the future. In the meantime, the GUI event loop is free to process the cancel button. And one of the things we do when we're done is re-enable the controls on the view. And then the view sparks back to life. Yeah?
Wait, so in this case, since there's a task, as soon as you click the cancel button, then it's going to automatically throw an exception and then pretty much jump out of the task and go into that final flow?
Well, it doesn't jump out of the task. What happens is we're passing in this token to post async. And we're also, okay, and what that means is if that token is canceled by the code that handles the cancel button, then post async will end up throwing a cancellation exception to tell us it has been canceled. So it'll cancel itself and throw that exception, and we have to catch the exception right here. And we got to make sure that no matter how this task ends, the last thing it does is re-enable controls. Okay, if it's not canceled, we're going to end up remembering that the user is registered before we end. All right, so that didn't look too bad. We took code that we had before. We had to change it somewhat. We had to wrap it inside of a task. What's going on here? In the first version we saw, when we got to this point in the code, we just did view.isUserRegistered equals true. Done. Why do we have to do this view.invoke, blah, blah, blah? Yeah?
I think that's maybe a duplicate.
Because what?
Might be a duplicate.
No, it's not that it's a duplicate.
The GUI will get matched.
What's that?
Will the GUI get matched if you're trying to change it on a different
Okay.
task?
So the problem is you can only do things to the view, remember, from the GUI event thread. So in our first version, we were doing everything on the GUI event thread, so it wasn't a problem. But now this stuff, this highlighted code, is running in a separate task. If we attempted to directly modify view.isUserRegistered, we get an exception. We can't do a cross-thread change to the GUI. And remember, the reason that rule is there is so you don't have to worry about concurrent programming when you write the GUI. You can assume everything's happening on a single thread. And so what we have to do to actually change the view is to do it via this, we have to call view.invoke and create a lambda to do our work for us back on the GUI event thread. So this code ends up being run on the GUI event thread at some point. Yep.
Parts in like if we're having multiple threads that are having like multiple user inputs, when you tell the task to manipulate the original GUI, would those sections be pretty good areas to have critical sections? Like, do you not?
Well, if you have, yeah, sure. If you have multiple users of a, well, even if you have multiple users of a GUI, that's, well, when does that happen?
Like if you're signing up for something and you try to log in.
Okay, but in that case, you don't have multiple users of the GUI, you have multiple users of the server. So yeah, the server is certainly multi-threaded. You have to deal with synchronization there. But what I'm talking about here is just the user interface running on your computer. It's singly threaded. So we have to go through that, and then later down here when we want to re-enable controls, we've got to do the same thing. So it's kind of annoying. You know, but it worked. We got our cancellation to work. Fundamentally, what we had to do was make sure that the code that could potentially stall out, in other words, the code that's going over the network, needs to be run on a separate task so as not to freeze the GUI. And then we sort of have to stand on our head whenever we want to change anything about the GUI from that task later on. We have to do it through the invoke method. Fortunately, there's a better way. Now, before I show you that better way, I'm going to show you about this. So, C# supports what's called the async await pattern. And you can think of it as an automatic transmission. I've seen it described that way in documentation. That in your situations when you're using multiple tasks for the purpose of waiting, you can use async await to really simplify things. So this async await isn't useful if you're doing multiple threads in order to compute prime numbers faster. If you're trying to use tasks to do work in parallel. But in our case, we were just using one task. We created our task just so it could wait on something. And so in that situation, this pattern is useful. So let's see what's going on. So this is sort of a stylized version of the code we were just looking at. So we got some method, and its job is to read, it's given a URL. Its job is to read the contents of the URL, and we're going to assume that read page contents might take a very long time. And then eventually it'll get a string back, which is the contents of the page. It'll do some stuff not involving S. It'll do some stuff to S. It'll do some other stuff that doesn't involve S, and then it'll return the string. So written that way, if you call it, you can't predict. It might take a long time for this thing to return, right? We just saw that. It just depends on how long read page contents takes to negotiate with the remote server. Okay, so this is a blocking version, and we don't like that. Okay? Now, this is a little bit different. It doesn't block immediately, but it blocks a little bit later. So what have I changed about it? We're still doing some stuff. But what am I doing with this part here? Right. I'm doing on a separate task. I'm starting up a task whose job it is to read the page contents out of the URL. So while that's going on, while this task is running, I do the stuff that does not involve S. Then I get to here, and I do read task.result. What will happen there? What does read task.result do? It waits for read task to be done and gets the result back from it. The result will be a string because it's a task that computes a string. And then when we get it, so the thread that this is running on will block while we wait for the task to finish, and then we continue on and return. So this is a little bit better because we're doing, at least we're doing this stuff that doesn't involve S in parallel with calling the server. But it's still prone to blocking. The thread can block for an arbitrary long amount of time. Okay, so that's one thing you can do. So this just punts and lets the user deal with it. This is sort of what we did in version 2 of the controller. So now I'm creating a task that does it all. It reads the page contents, which might take a long time. It does the stuff not involving S. It does the stuff involving S, on, and it returns S. So basically we're saying, here's a task, and return. So notice that this method here returns a string. Version 3 returns a task that computes a string. So whoever calls version 3 is going to get back a task, and they can choose to wait for it if they want to, or they can choose to do something else in parallel. But we just wrap the whole body into make the whole body a lambda that's passed to run. Okay? Here's a simpler way. So I want you to notice first the differences. I've declared this method async. I have changed it from returning a string to returning a task of string. And down here, instead of saying read task.result, I'm saying await read task. So async and await go together. You can't put await, you can't have the await keyword in a method unless the method is declared asynchronous like that. And one other change is, I'm assuming that there is a version, there's a method called read page contents async, which is itself, well, yeah.
Will the compiler catch it if you don't have?
Yeah, the compiler will complain if you do that. Okay? So the question is, what does this do? So what I'm going to do is step through and show you what happens when you run this. So the method is called, so we're still in the main thread. It does some stuff. It makes a call, and so I'm assuming that read page contents async doesn't return a string, it returns a task that computes a string. Okay? So that's a non-blocking call, so we immediately get back the task that's off reading the contents of the page. We do some stuff that doesn't involve S, meanwhile that read task is doing its thing. And then we hit this await. Now, if this said read task.result, we would block until the read task was finished. When we say await read task, what happens is the rest of the method, the rest of the code in the method is automatically put into a task, and that task is returned. Okay? So we don't have to manually create, say, new task and put everything in braces. It's just automatically. This just says, when you say await some task that's returning, when you await some running task, it just says, all this code in white, stuff it into a task. So it creates a new task that waits for read task to be finished, and then it will take the string, do stuff to it, do more stuff, and then return the string. So it automatically creates the task for you. So that means when it's called, it executes all the yellow code, and then it returns a task that's going to do the white code sometime in the future. But it automatically packages your code up as the code to be run by a task. So you'll see that we didn't have to create any tasks here. You don't see new task or task.run or anything. You see, you just see the async and the await to make it work. Okay? So let me show you this in practice. Where are we? To-do list, client. I need to use controller 3. And let's go look at the register method, the one we've been looking at. Okay, so I have declared the method async. Now, I've also declared it void. So register was void to begin with. So typically, if you're making a method async, what you have to do is, if it originally returned a string, and you're making your method async, you've got to declare it to return a task that returns a string. If the method is void, you can either, you got your choice. You can say register returns a task that computes nothing. It's just a sort of a void task, or you can just leave the method void, and that's what I've chosen to do. Okay. So I've created an asynchronous method out of this register. It looks the same as the version 1. It enables the controls. It creates an HTTP client. It creates the parameters. Nothing about tasks. It does everything up until it calls client post async. Before we did client.post_async.result, we blocked and waited for the task to finish. Here we're awaiting for the task to finish. So what's going to happen? What will be when we push the register button and the code executes up to this point, what will happen next? What does that await by for us?
So we put the rest of that in the task.
Right. It creates a task that waits for this to be finished, puts the response in this variable, executes this code, and then task ends because there's nothing to return. So that means that this call will return immediately. This code will immediately return and leave behind some task that's going to run to completion sometime in the future. And then the GUI can go on with his business because this task was just spawned immediately. So contrast this with controller 2, where we had to actually create the task that did the rest of the work. Here, the task is created for us automatically just by putting a wait right there. Now, there's one other cool thing. Do you notice any other differences between this and version 2? Let me see if I can get the relevant things on the screen here. How is this simpler than version 2? Yep.
You don't have to do the dot invoke.
Don't have to do the dot invoke, because the guarantee, one thing that this system guarantees is that if the await occurs on the GUI event thread, the task that's created will run on the GUI event thread. It'll be run on the GUI event thread sometime in the future. So we don't have to do the invoke. It's all handled automatically for us. So we can just take, essentially, we just took the code that was in version 1, the straight blocking code. What did I have to change about that blocking code to make this non-blocking version exist? What did I change in the header?
Just added the async.
Right? I declared it async, and I put a wait right there. And actually, having a wait right here as well, because this is also a blocking thing. Okay, so I just put a wait in front of the methods that return tasks, and that's all I had to change. So it can be tricky to understand what's going on, but it's simple to use. You just label your method async. If there's a return type here, you need to make it return a task of that type instead of the task. And then you put your awaits in strategic places, and you're done. So when you're doing PS9 and you're needed to make actions in the GUI cancelable, this is sort of your template for doing it. You can write the handlers assuming that you're okay to block, and then just modify it using this async await pattern. And that's why it's like an automatic transmission. You don't have to worry about shifting the gears, changing the, rewriting your code up to make it, to take advantage of tasks. It takes advantage for you. All right, so there is what I've shown you here is how to write a client. So you're going to be writing a client for PS9. So what I want to accomplish next is see if there are any questions I can answer. I've done a lot of talking here. Are there any questions I can answer about creating a client? And then I'm going to show you the API you'll be using. So let's take a break. You be thinking about questions. Okay, so we're going to look at the client. So I kind of don't like to show you my, this is my Boggle client running against my Boggle server. So I've got a Boggle server running on my laptop. And this is a Boggle client I fired up. I don't like to show it for several reasons. One is it's kind of ugly. And two, once you see it, you might think you have to make yours look like mine. So this is just how, the easiest way I can think of, you can, your Boggles can be different. All right, so let me, since it's, the fonts are so small, I'm going to shut the lights out just to play the game. So the idea is you're going to create a client, and there's a server. And so you go and you type your name in here, and you type in the URL of your server. Okay? So I have localhost colon 60,000 because it's running on my machine. Now what I'll do before I get PS9 out is I will put my server running on a real server machine in the KDLab. And so there'll be some KDLab address you want to use as the server you're running against. And then I register as a Boggle player. So I click user, and you saw it took a fraction of a second to register me. Now what I can do next is join a game. And so when I click join game, what's happening is it's going out looking for another player that has also clicked join game. So the first person that clicks join game and waits and waits and waits until the second player comes along and says join game, and then those two players will be paired by the server and they'll start playing. Unfortunately, there's no one out there to play against me. So I'm going to cancel.
We can join.
Well, now my cancel button doesn't work correctly. What the cancel button should do is remove the request from the server. Tell the server, no, never mind, I don't want to play after all. But I wrote mine differently so I could do this demo. Because now what I can do is I can register as a different user. And now I can play against, there's still that phantom request out there to join a game. And so this is, again, one side is going to be played. The other side doesn't have a client talking to it now. So now I can play a game. So when you join the game, up comes a grid of letters. And the point of the game is just to find words you can make from the grid, like, let's see, what can you make? Rail? Gray, G-R-A-Y, right. So you can go horizontally, vertically, and diagonal to put things together. So you see my score became 1. So then there's like had, H-A-D. Right, and there's grab, car, CAD, clad, and so on. So you get points. The 3 and 4 letter words are worth a point. Longer words are increasingly more valuable. Anyone see a 5-letter word? Cliff? G-L. How do you get glyph? There's not a Y next to the L. Clad? Clap. Plaid. Okay. Okay, let's see where that is. P-L-A-I-D. Yeah. If there's an S on the board, then it gets easier to make longer words. So anyway, normally what would be happening is, your opponent would be entering words too, but the opponent is orphaned right now. You see the time ticking down, and then when eventually the game is going to end here in 15 seconds, 16 seconds. So let's see, bay is a word. All right, now everything you're seeing is happening via interactions with the remote server. Now when the game ends, I could quit the game here prematurely, but I'm not going to. When it ends, it displays on the right here the words that I entered and the score I got for each one, and it displays the other ones over here. And there's scoring rules that, like if you enter something that's not a word, you lose a point, and you don't get credit for entering the same word twice and stuff like that. That's what the game looks like. And then it needs to be such that I can now join a new game and continue playing. Okay? So that's Boggle. Next time I play, I'd get a different board. Some boards have more words on than others. Sort of depends on the vowels and where they are. So that's the basics of the game. So what's the first thing you're going to have to understand in order to write a client? What ought to be your first question? You sort of see what you got to have. You got to have a board and some buttons and what? Back there, yeah.
How do you get the same game to 2 clients?
Okay, so how to get the same game to 2 clients, which is, that's true, something you need to know, but it's part of a bigger question. Yeah? Well, how do you get the players together? I mean, how do you find out the letters on the board? Basically, you need to know the API. Okay? So let's look at the API. So what I did was I fired up the server so I could play Boggle. And this is the API page that it brought up. So the API is here. Now, I have this link I've added called Full API Documentation. And I haven't finished all the details, so I won't dwell on it. But this gives more detail than I could format on the other page. So you need to read that to find out exactly what's going on. But this is a good overview. You can see that the server provides 5 endpoints. Okay? So let's look at the endpoints. And these are the endpoints this is all you can use to communicate with the server and get games going with other players. So they're sort of written in the order in which you might use them. The first one is to create a new user. So let's go see what it is. Okay, it's a post request to Boggle service /users. What would come before Boggle service? What would come before that in the complete URL? Where's the rest, or where does the rest of the URL come from? Yeah, the URL of the server. So in my case, it was http://localhost:60,000. And when with you, it'll be something different because my server will be running on a different machine. So it takes whatever the user enters as the address of the server to communicate with the server. Then you would need to do a post request and stick this on the end of the URL for the server. Okay? So it's a post request. Let's see what goes. It says there are no parameters in the URL itself. And the body consists of a string, which is the nickname of the user. So that's the Joe. So that tells you that to register Joe as a user, you have to send a post request to that URL with the string of the name of the user in the body. And then the server responds with a token that uniquely identifies the new user. And that is in the string form. All right, so let's say you do that and you realize you don't really understand how it works, or you want to experiment with this thing and make sure you understand what this user's endpoint does. So what do you do? Well, you could look at the full details, but maybe you're still confused. Yeah?
Can you go to that API testing?
Right. So there are lots of things like this, but I suggest you use the Advanced REST Client, ARC. So we should be able to go over here to ARC, it'll come up, and use my server. So let's see. I don't know what the heck's going on here. Try again. There we go. Okay, I'm just going to hijack this tab here. I think I have too many tabs too many open tabs in this thing. Okay, so let's go to http:// Wow, this thing is really lagging. localhost, man, 60,000 slash, and it's going to be Boggle service slash users. Not to go look, remember how it's spelled. Yeah, lowercase users. It's a post request. And we're using JSON. I don't want that except to be JSON. I want it to be, I don't want it to be XML, so I'll change that to JSON. And we got to put something in the body. And we got to put in the body is something like Joe. That's a JSON string, just like a C# string. So I've got this all set up. I've got the payload in the body. I've got the URL. It's a post. I should be able to send it. And I get back 200 OK. And right down here at the bottom, if you can see it, is the string I got back. It's a globally unique identifier generated by the server. And so anytime I want to I got to tell the server who I am. This is basically my ID. It's designed so that no one else can guess it. It's too long to guess. So it's, as long as you keep it private, it's secure that way. Okay? So you can experiment with the things over here. Okay? So just imagine that client. When someone clicks register user, you've got to fire off that post request and get back that ID, that token, and remember it. All right, let's see what else you can do. Join a game. So you can post to Boggle service / games to join a game. You get, let's see, okay, there's the URL. There are no parameters in the URI. The body consists of a game request object, which has a user token property and a time limit property. One's a string and one's the int. So basically you're saying, here's my user token, the one that was generated with that previous call, and I'd like to play a 60-second game. And you send that request, and it says what comes back is something of this form. What comes back is an object with a game ID field, which is the identifier of the game that you need to keep, and then is pending, which is either true or false. So if is pending is true, that means that you don't have an opponent yet. You've got half a game, you're waiting for an opponent to join it. If is pending is false, that means the game is ready to play. So that's how you tell the server you'd like to join. So if two clients submit this, this post request to the server, it'll pair them up. It'll respond to each. Well, it'll respond to one saying you're in a pending game. It'll respond to the other and saying you're in a non-pending game. The game has started. Okay? So that's how you request a game. What else do you need to know? Let's say you've registered as a user. You have used that token to start a game. You have a game ID, but the game is pending. What do you suppose your client would have to do?
It needs to wait for the game to go on.
Right. It needs to find out if the game, it needs some way to find out the game has started. Okay? So let's see what the API can do about that. This method here is the one. Let me click on it. So this one, which is, it's a URL that says is games. That's how you find out status about an existing game. So in the URL, you include the game ID that you got back, and you give true or false depending on whether you want complete information about the game or brief information about the game. So game ID goes there, true or false goes there. What comes back, this is the full-blown thing that comes back. You get less of it when you get a brief response. You get the game state, which is a string, which is either pending, active, or completed. You get back the board that's being used for the game. You get back the time limit for the game, the time left in the game, information about the words played by the players, and so on. So you get information about the game. So if your client is just waiting to see whether the game has started yet, whether someone's been paired against you, it'll probably just make a request, and all you care about is the game state. So what you have to do is have a loop of some kind that well, probably not a loop, you'd use a timer, so that every second, say you query the remote server, you ask, what's the state of the game? Once it goes to completed, you know the game has started. Okay, so the game, you just found out the game has started. What do you do now? What's the client have to do? What's that?
Enter words.
Well, before you can let the user enter words, you have to display the board, right? But you can find out what the board is from this request. Right? So when you made the status request, you can get back, one of the things you get back is the board. So you get back a string that shows the letters in the board, so you can display the board, and then you can start playing. Now, as we're playing, the timer ticks, and the scores, you know, our opponent's score, we're going to see it change, and our score, we're going to see it change. How do we find out about that? Where are these scores coming from? They're coming from the server. How do we get the information from the server? Yeah?
Same thing, we just probably continually or recursively update the board
Right.
on some sort of delay.
Right, so once the game starts, maybe every second, you ping the server and you say, give me a game status. And I think it's designed so that if you ask for a brief status, you'll get back what you need, which is essentially what you'll find out is that what you care about is the time left in the game and the score of each player. So by issuing this GET request over and over again, you can you can see what time is left and display it. You can see what the two scores are and display them. That's why you may have noticed a little delay between when I typed a word and when the score showed up, because when I type a word, it would go to the server, and then I would ask for a status update, and it gets updated. So the thing to realize is, in a RESTful API, the server is not going to be pushing out information to you. It's not like the server says, oh, the score has changed, I must tell the client. The server is passive. If your client wants to know what the score is, it has to ask the server. It's up to the server to query the client. It's up to the client to query the server, not the other way around. The server just responds to requests. It doesn't initiate anything. Okay, so you've got the board working, the clock's ticking. You pick some words. The user enters a word, or you could have them click the word on the board if you want to. But anyway, somehow a word is played. Okay? What do we have to do with that word? Okay? Right here. There's a put request to play a word. So let's go look and see what it does. The game ID shows up in the URL. So here's the URL, Boggle service /game/ and the game ID goes right there. Okay? In the body is an object that contains your user token, your player's user token, and the word you're trying to play. And it responds by telling you, it responds with an integer, basically the score that was earned. Okay? So that's another endpoint for playing a word. And finally, there's a method to cancel. So this method here cancels a pending game. So if a game is pending and you're tired of waiting for someone to play it, you can send this to the server. So the URL is just all it contains is a user ID of you in the body, and that cancels any. If it's pending, it'll cancel. If it's not pending, it won't cancel it. It'll just ignore. Okay. So those are the 5 endpoints. So it's a pretty simple interface. You've only got 5 things you can ask the server, and you use that as the model for your GUI, which is your client, to conduct the game. Yeah.
In your more in-depth API description, will you put the rules of the game, or will we have that in the PS?
Yeah, the rules of the game will be in the problem set description. The more detail, like the detailed documentation says what exactly is returned when you get status back, in the case where it's brief or the case where it's not brief. It tells you what status codes are returned. Sometimes when there are errors, different status codes are sent back to indicate different errors. Now, to make your life easier, I'm giving you a Boggle board class. So you don't actually have to implement the game itself. Okay? So I'll give you a class that represents a board. It has a method that will tell you whether a word is legal, that sort of thing. So that'll be done for you. You just got to use that class in your, well, actually, I'm ahead of myself. That doesn't matter for the client. When it gets to your server, when you write your server, which is starting with PS10, I'll give you that class. You don't need the class for the client. So you don't have to know the rules of Boggle at all to write the client, because the server is the arbiter of the rules of Boggle. So you just need to know to send it words. Yeah?
When we're implementing the next assignment, do we have to use MVC architecture? Like where we have to create like a stub just to test?
Okay. Okay, so he asked an important question. So for PS9, I'll just tell you the answer. You can design, it's completely up to you how you want to design the architecture of your client. You can use the MVC architecture like I advocated for PS7, or you can not. It's just up to you, whatever you think is most effective for you to work. And I'm not going to require any unit tests. You can unit test it if you want it or not. We'll test it just by playing. Yeah?
Are we making the view as well for it? The view part of it?
Yeah, you'll need to make the view part of it.
Okay.
So, I don't know, for mine, I probably found some, I don't even remember how I made the central display of the board, but there are widgets in .NET you can use to make things like that. And I encourage you, see, what I don't want you to do is go to the videotape and look at what mine looks like and try to copy it. Because like I told you, mine looks crappy, and you can do better, so do better. Just, I've seen some really artistic Boggle games over the years. But to make this work at all, you've got to know how to attack the problem of creating a client. So once you understand the API, what do you do? Let's just talk about how your work would proceed. Sometimes it's hard to get started. What would be the next step once you understand the API and have played with it a bit in the Advanced REST client? Yeah?
For one of them, like say, getting whatever the game status is, you need to be able to take the information that it gives you, make it into part of your model and control it.
Okay. So for each of the things you want to do, for each of these endpoints, you'll need a method that takes parameters, packages up the parameters in the right way, makes the call, gets the response back, and returns the answer. So I'd recommend a method oriented toward running each endpoint, just like I have a method for each endpoint in my to-do list client. But what I expect you to say is, first thing you'll do is design a layout of some kind, right? You'll fire up the GUI designer, you'll lay out the pieces that you need, get that all going, and then write code to respond to events. And the only way you have to respond to events is with these, by running, making queries against the remote server. Now, one thing you'll find out pretty quickly is all of you, come next Thursday, will be trying to get you're working in pairs, but you're trying to get your clients working, and you're all banging against my poor server. Hopefully, I used to put it up on Azure. They used to would give me a free account, and I would host it on Azure on the cloud, and I could basically turn a virtual control, and allocate more cores to my server. But they've stopped paying for that, so I just run it in the KLab. And it wasn't a problem last time. It's possible the server could slow down. But you may be sitting in your client saying, okay, you may fire up but say you and your partner on different laptops. You decide to play each other. So you fire up your client, you click join game, your partner does the same thing, and you discover you're not playing against each other, you're playing against other people. Okay? So bear in mind that you're not the only ones using the server, and so it's sort of random who you get paired up against when a bunch of people are developing. Yeah.
It does pair at the wrong time, right? So if you select a unique time amount,
Oh no, it doesn't. It doesn't pair based on time. When it pairs two people, it just averages their requested times.
So it just takes two.
Yeah, it just takes the. As soon as two people join, it pairs them up. So you just got to be sure that if you and your partner click join at about the same time, you'll probably be. Well, no, you got to fit. There may be. It's hard. But if your goal is to test your client, you just have to. It's no problem playing someone else. Okay, so that to-do list server is a good thing to look at. Look at the version 3 of the controller, which uses the async. Because one of the things you're required to do is to be able to cancel out of things. In particular, to be able to cancel out of, things when they're taking too long. Like if it's taking too long, if the server goes down, or the server's taking too long to respond to anything, you need to be able to cancel out. Yeah.
The game itself that we're not adding any function to that or changing anything around, we're just doing purely API usage.
Yeah, I mean the API won't change. You just got those 5 endpoints to worry about. So you get started early, take your time. It's not it's not that bad. It's not any. I don't think it's any harder than in fact, it's probably easier than the spreadsheet GUI, just because the model is simpler. Right? There's only 5 things you can do to the model. The fact that you're going over the web to do it is, adds code, but doesn't really make it harder. Okay, and then PS10, you'll start actually recreating my server. That's a topic to discuss next week. Okay, we'll end here and we'll talk about servers next week.